Hello, everyone. Welcome again to another Calypso Tips session. I'm Steven from Learn CMM, and I'm happy to share with you 20 years of experience, all kinds of tips and tricks. We're going to practice programming again today on the part we left off last week. This has a bunch of angled half cylinders in it. And as always, leave your comments or questions in the chat. We definitely want to cover anything you have a question on. I'm flexible. I have a couple other parts loaded in my Calypso that we can look at. I'm going to share my screen here. Just a second. So we are picking up where we left off right here. All right, so this is a unique part because of these angled cylinders, it's a little bit trickier than normal. So we're leveling off of the top plane. We're using a circle on the outside diameter for the XY origin. And then our angled cylinder is what we use for the clocking. We create an intersection between that angled cylinder and the top plane. And that intersection is what sets our y-axis. So before I go any further, I just want to make sure I have the probe travel and angles all set up properly. So we're going to simulate that now. So we'll turn on our simulation. Our probe is angled. And if you want to see how we set that angle, refer to the last video from last week. This angle corresponds to the angle of the cylinder. And in our measurement plan editor, we want to make sure that we have that stylus set up to the correct one. So this one, we're using the 8 minus 10, B minus 20. Okay, so let's give it a try here. We're going to run the program as if we were running it physically on a part. We're using the manual alignment. So go ahead and click Start. Okay, so we're going to take our points in the top plane. All right, something went wrong. I'm going to delete. If you accidentally take the wrong point, just click Delete Probing Point. There we go. And we'll just take 3 for the manual alignment. Okay. Take our OD. And then the probe angles. So now we're going to take this cylinder. And notice how the probe is not touching the part where we want it to. And that's an issue that I've seen before, and I can show you how to fix that in the simulator. Okay, so we've got those 6 points. Okay, I'm going to run it through the base alignment features. Speed this up. So yeah, the Calypso planner simulator can be a little bit finicky and buggy when it comes to the RDS if you don't have it set up properly. So we're going to go back to our Stylus system. And notice how this A minus 10, B minus 20, the coordinates of it and the radius and everything are all 0. So that's a problem. We have to set it up so that those angles will have some type of coordinates. Otherwise, the CMM doesn't know where that probe angle is. So what I'm going to do here is I'll delete that bad probe angle that has no coordinates. I'll go into my Stylus System Management. Under Stylus, right here, this A minus 10, B minus 20, I'm going to delete that. And then the way to add angles in the simulator with the RDS, I'm going to use this Rotate Stylus button. And then you can add it here or here. There's a styli list where you can add new angles. I typically go here instead of anywhere else. So down in here, we can add a list or another tip with this button. So this is going to be our A minus 10, B minus 20. This is going to be number 6 because 1, 2, 3, 4, 5 are your regular down and XY directions. A minus 10, B minus 20. All right. So there we have our angle. It's going to show a preview of where it's at. And then right here, if we click Create New Stylus System, it's kind of misleading, but we're actually going to update the existing stylus system with this angle. And then it's asking, which tip am I using in case you have like a 2-direction star probe? Otherwise, just click OK. And then you just say yes, close this. And there we go. So now we notice this probe angle has directions to it. So when it goes to index in the simulator, it's actually going to work, hopefully. Sometimes Calypso has a mind of its own. All right, so let's try this one cylinder again. If you're debugging a program and you need to do one feature, there's a couple ways of doing it. You can right click and execute. So it's going to drive to that one feature and measure it. Keep in mind that's going to be top speed. It's not going to have the speed control as defined in here. So you might want to put your hand on the dial. It will go to the clearance plane though. So you have that. The other way is to right click and delete actuals and then go to run and do current selection. And make sure you uncheck clear existing results because otherwise it's going to try to run the whole program all over again. So we'll click start and then it's going to go. Now it's at the correct angle and that's good. But you notice it seemed like it was driving right through the part. I'm going to run that again here. I'm going to turn on the collision detection. Yep. So right here, if I click this collision, it's hitting the part as it wants to go back up in Z. So this is another issue that's pretty common. If you're measuring an angled hole, but you need to come in from a clearance plane, how do you approach and how do you come out of that hole? So what you'll do is you'll go in the cylinder, in the strategy, in the clearance data, and we want to put in a larger number for the clearance distance. So this is going to be from the last scan path that it's measuring. And so we have about 15, 20 millimeters between these scan paths. So let's say we'll do 50 millimeters just to give us plenty of room. So let's see how that behaves now. So execute this. So notice how it comes in with some clearance before and after. I'll just play that one more time. It's kind of fast. So we've got this clearance distance and it's diving in and then it goes back up to that 50 millimeters. All righty. So a couple questions, we're going to address those right away. Kalika is asking, how do you do calibration of the RDS and add a new probe? We did talk a little bit about that on the last session, so you can look at the previous video. In summary, you're going to have to qualify your reference sphere with a master probe. Then you would add any new angles using this dialog. And then you would qualify each individual angle. So there are 2 different ways of qualifying the RDS. The way I'm showing you here is where we have each angle is a separate stylus. The other way is when you create a new stylus system, you call it as an RDS CAA, which means there's going to be only one stylus, and it will qualify 12 specific angles on the reference sphere. And then you can define any possible angle in the measurement plan editor. So that would be in here. You could say, I could do A15 and B28 or something like that. So with the CAA option, it gives you more flexibility, although I've heard it's slightly less accurate. So that's good for aerospace parts or complex castings where you got to come in on all kinds of angles. So I'm going to go. Okay, let's move on to the next question. Murat is asking a question for you. I want to duplicate a feature such as a circle. I've created two patterns for one for part, second for duplicate for the part. Okay, I'm trying to wrap my head around the question. So you want to use a pattern as a multiple measurement. So you're trying to duplicate a circle. You have two patterns, one for the part and second for the duplicate part. I'm not sure if I understand the question exactly. With patterns, you can duplicate the part or the feature and the pattern with it. But maybe you could rephrase your question, or I don't think on the chat, can you send images on the chat? Okay, sorry about that. I clicked something and then it got me out of the live stream. But yeah, Murat, if you could clarify your question a little bit more, that would help. Okay, another person is saying, I'm pretty sure you can't make the pattern you do have where it gets both and exclude everything else. I'm thinking maybe you're talking about a pattern within a pattern. I'm not sure. Another question. Clearance paths in CAD settings. Okay. So we did cover a little bit about the clearance on this one unique feature, but if you're new to Calypso, when you're creating a program, generally it's easiest to make the program with the clearance plane feature. So this is where you define an imaginary box around your part, and each feature you measure will come back to one side of those boxes. So in the feature, you'll notice it says CP plus Z. So when we're measuring this feature, it's going to come down, scan that surface, and come back to that clearance plane. All right. Sorry about that. I didn't share my screen again. Okay. Thanks, Jonathan. So I'm just going to continue on this part, and then we can dive into some more things about patterns. That seems to be a topic that we want to cover. So we already got this one cylinder in there. That's successful. But let's say I want to get this other one on the other side. So I'm going to extract features, get that cylinder, and I can use the paintbrush to transfer the strategy from that original feature to the next one. So I'm going to click Copy Properties. And I do need to change the start angle. So I'm going to adjust that. Keep moving it until it gets the right place. How about 220, maybe a little more. So you'll notice this one, the strategy doesn't transfer exactly the way we want it. So we have to go to each one and just adjust as needed. Okay. Adjust this one. Okay, so what's the whole point of measuring these cylinders? Well, for one, we'd probably be interested in the diameter. So we can report that. We can put it in as just a regular plus or minus tolerance. But we also might be interested in the location or the angles of those cylinders. So if we did the true position of just that intersection point at the top, that's not going to tell us whether or not that angle is correct. So let's take a look at how we can achieve that. So when we do a true position on a cylinder that's at an angle, normally most parts your cylinder is going to be perpendicular to the surface, not like this. And you'd have a diametrical XY zone. But in this case, X and Y, that's more like two-dimensional. We want to consider the entire zone of that cylinder in 3 dimensions along the axis. So you'll see these little icons right here. These are allowing you to set the zone of that position tolerance. If I click on there, notice this yellow line. Our tolerance zone is perpendicular to the top, and that's not what we want. So if we change this to a polar zone and go here, now we're checking this, not only the XY, but the angle at the same time. So this is the preferred option if you have an angled cylinder. And now it's considering X, Y, and Z coordinates. For the purposes of the machinist, if you're trying to set offsets and stuff, you would also record the location of the intersection. Let's say we want to check the specific angle of this cylinder relative to a center plane. So this is a compound angle, and we're going to have to check it possibly in 2 different ways. So first I want to make an alignment where I'm centered between these two. So I'm going to make another intersection where I go plane 1, cylinder 2. There we have those 2 intersections. Then after that, we'll make a midpoint using a symmetry. That's under construction symmetry. And then we go intersection 1 and intersection 2. Then we can create an alignment where our planar rotation is coming off of that symmetry 1. So you'll notice now we're lined up that way. And then I'm going to create a theoretical plane. Let's go options, theoretical. Give this a size. And this is in the X axis, facing the X in alignment 1. And there we have our plane. So now we can measure the angle between the cylinder and that theoretical plane. So go cylinder 1 and plane 2. So that gives us the angle this way. You could do the same thing with a plane in the other direction. All right. Okay, more questions. Can you explain how to do alignment during shafts and normal alignment? Okay, measuring 6 parts at the same time, making patterns, everything. I have, let's say, 12 circles. I'm making a pattern in the first part, and I want to duplicate the pattern for the other 5 parts. Okay, now that makes sense. So you're having one program to measure a bunch of parts at the same time. So you have maybe a circular pattern in the part, and then a linear pattern for the other parts. First of all, I encourage everybody to not do a program with multiple parts in one program, because it becomes a management nightmare sometimes. If you're doing an update or a revision, you're going to have to update all the features in the pattern everywhere, and it gets to be really tricky. So the better alternative for that, what you're trying to do, is using the Calypso auto run. So if we close all of our programs, we can switch over to auto run. Close this one. And okay, close this one. Because you can't open auto run unless all other programs are open. So we go to plan auto run. So what this is, it's basically a interface or a desktop for operators only. But it also allows you to create palettes or patterns of programs. So let me know in the chat if you want to dive into this in more detail on how to set up, palettes of parts. But basically, you choose the program that you're wanting to run as a multiple or palette program, and then you would set up the increments or the offsets between them. So here we have our program. In the auto run, you can have individual programs like I just did, or you can do a palette. So in here is where you would define the spacing in XY and the alignment of the palette and so on. So like I said, let me know if you want to dive into that next time. We can definitely do that. But if you're trying to make a program where you have multiple parts inside the same program, I'm not saying you can't do that. I'm just saying it's more challenging. In order to do that, you have to, I'll just show you kind of in summary what I would do in that situation, because I have had times where a customer wants that scenario where they want all the parts in one program. They don't want to deal with auto run. So it is possible. We just open up an existing program. Let's just use this one. Sorry about that. For some reason, I keep disconnecting. All right, anyways, I had a question. It says, I want you to go over stuff no one knows. I'm trying to learn stuff you can't get anywhere else. So maybe you can specify your questions. Some of this is beginner level, some of it's advanced. So we're covering a whole bunch of stuff. Let's share. Okay, so some issues. I don't know what's going on here. It keeps kicking me out. All right. So anyways, we're talking about how do you create a program. Inside the program is actually multiple parts. And so how I would do that, if I had this program where I had a pattern, let's say I'm patterning this cylinder, so options and pattern. I'm going to do a rotational pattern. And then I'm going to go 120 3 times. So there we have those 3. Okay. And then we want this part to be patterned, in the X and Y. So we have 6 of them. So what you're going to have to do is you're going to have to create copies of all your features, and then you're going to have to create secondary alignments for each part, and then you're going to transfer them. So it's not going to be a straightforward pattern within a pattern. So what you would do is, first of all, create an alignment that defines your offset. So I'll go special offset. Let's say I'm going 100 millimeters off in the X. Probably want to go more than that. So 200. Okay. And then based on that, we can copy all our features. Let's say we'll copy these and this one. And to help us, we'll put this in a group. So now these features, I'm going to transfer them over the 200 millimeters by using the keep position option. So I'm going to click keep position before I choose alignment 2. Because alignment 2 is our offset one. So let's rename this. Okay. So I just shifted this 200 millimeters. So I'm going to do that on all these. Okay. Now you'll notice the pattern of this one is messed up. So we have to go into here, into the pattern, and create a new pattern where our pattern is now centered on this offset alignment. Okay. So now we got to fix the number of features here. Okay. So now all these features are theoretically 200 millimeters over to the right. But what I want to do for these is actually create another alignment where we're locating off of these alignment features. So then I would go and create another secondary alignment where we level off of this third plane. It's also our Z origin. And our XY is off of the circle 2. And we would also have another one of these intersections. So this would be off of plane 2 and the cylinder 3. Okay, so we're recreating everything over on the other side. And this would be kind of like our base alignment number 2. We can say part alignment 2. And then everything after that would be referencing that part alignment 2. So we would call this one part align 2. So it is a multi-step process. If you're having multiple parts in a program with rotational alignments and linear offsets, you are going to have to do a little bit of extra steps to get there, but it can be done. All right, a few other closing things. If you don't have curve module, you can always use the point distance, but it'll be a headache for a lot of points to analyze. Yes, sometimes that is the case. Sometimes even if you do have curves, you might even use points, space points instead if curves are not necessary. For example, if you have a machined part that's like an aerospace and has lots of pockets that need a general profile with a large tolerance, you could do a sampling of space points instead of curves all over the place, because that would be overdoing it. Any other things here? There's a lot of comments today. That's great. Can you pattern the weird cylinders? You would need probe angles different for each. Good point. So that's very important. I'm glad you brought that up. So when you pattern a feature where the probe angle is specific, the probe angling does not pattern. So in this case, I could not get away with this shortcut. I would have to create each cylinder separately at a separate angle and then have separate probe angles. So that's one limitation of Calypso. All right. Wow. There's a lot of cool things you can do just in one part. So yeah, let me know if you do think of any other questions throughout the week where you're like, hey, I'd really love to cover this topic next time. Email me, Steven at learncmm.com. That's STEVEN at learncmm.com. And just let me know what your question is. I'd love to cover it if we can. And again, we'll do this next Wednesday at 11 Central Time. So yeah, I hope you have a great week. And thanks again for joining. It was a good time.